All right, today they're going to be asking us if the particle is speeding up or if the particle is slowing down. Now, in order to figure this out, we need to know what is the acceleration and what is the velocity at that time. So for our first example, we're going to pretend that t was equal to 1. And if our velocity was positive at that moment and our acceleration was also positive at that moment, then we would say that the particle is speeding up. So the velocity being positive means that we're going right. So you can see we got a guy on a motorcycle traveling to the right. And our acceleration is in the same direction. It's also to the right because it's also positive. So that's kind of like a gust of wind, and it's pushing in the same direction as the motorcycle is already traveling in. So we would say that he would be speeding up in this situation. Or it would be the same thing if your velocity was negative. That means you're traveling to the left. And if the acceleration was also negative, that doesn't mean you're slowing down. It just means that the acceleration is in that direction. So acceleration being negative means that the acceleration is to the left. So again, the velocity and the acceleration are both in the same direction, which is to the left, when t is equal to 2. So then at that moment, we would say that they would be speeding up. Now our second example over here on the right side would be slowing down. So instead of them helping each other because they're going in the same direction, they're going to be fighting each other because they're going to be going in opposite directions. So for our first example, when t is 3, if your velocity was negative, that means you're traveling to the left. But if your acceleration is positive, that means the acceleration is to the right. So it's going to be fighting against the velocity of the motorcycle. So it's kind of like if a big gust of wind came and blew against you in the front, it would slow you down. Another example of slowing down would be if your velocity was positive, so you're going to the right, but your acceleration is negative. So your acceleration is going to the left. Again, it would be kind of like a gust of wind that's pushing against the front of you. And so obviously that would be slowing you down. So basically, if your acceleration has the same sign as the velocity, then you're going to be speeding up. And if your acceleration has an opposite sign of your velocity, then you're going to be slowing down. And it's basically that simple. So what that means is that you're going to have to find the velocity and the acceleration at that moment in time, and just to see if they're positive or negative. That's all that really matters. It doesn't matter how big it is or how small it is. It just matters if it's positive or negative. Now let's go ahead and take a look at an actual example. Okay, for this example, it has two particles that are moving along the x-axis. The time interval is from 0 to 6, and it gives the position function of particle p. It says p of t is equal to 2 cosine of pi over 4t. Now we don't even need that. If you were to read the question asks about particle r, but we also have the position function for particle r. It's listed right here. It says r of t is equal to t to the third minus 6t squared plus 9t plus 3. So I've got that listed here. This is the position function. It wants us to find the acceleration of particle r at time t is equal to 4. So in order to find the acceleration, we have to do the derivative twice. So if I do the derivative once, I get the velocity. I'm calling that v of t. If I do the derivative one more time, I get the acceleration. So I'm calling that a of t. But it wants us to find the acceleration when t is 4, so we have to plug in our 4 for the t. And after plugging in a 4, I'm going to get 24 minus 12, which is just 12. Now what's important is not that we got 12. What's important is that we got a positive. So that means that the acceleration is to the right. The second question it asks us is they want to know if the particle is speeding up, slowing down, or doing neither when t is 4. So we're going to have to find the velocity at that moment in order to figure this out. We know that the acceleration is positive when t is 4, but what is the velocity when t is 4? Now remember, we do have the velocity function, so we can come back and just plug in a 4 for the t, and then we can simplify. If we simplify this, we're just going to get a 9. Again, the 9 is not important, but the positive is important. If the velocity at that moment in time is positive, it means that the particle is traveling to the right. And then the acceleration was also positive, So it's kind of like a gust of wind that's also pushing it to the right. So in this case, we're getting positive for the velocity and for the acceleration. So we would say that the particle is speeding up when t is equal to 4. Now it does say to explain your reasoning. So I'm going to go ahead and write a complete sentence that explains this. All right, there we go. You can see my reasoning at the bottom. It says here to explain your reasoning. So that means I need to write a complete sentence explaining the meaning of all this math that I just did. So I'm going to go ahead and say when t is 4, so that's important because it's at the moment when t is 4, particle r is speeding up because the acceleration is in the same direction as the velocity. So this is not the only way to say it. There's a lot of ways you can do it. You can put it in your own words. You could say that the acceleration and the velocity were both positive. That would be a good reason. And don't worry about explaining any further. It's not your job to explain every single little detail of it. Just the fact that our velocity and our acceleration were both positive is enough to say that the particle is speeding up. So that would be a valid reason if you just said that the acceleration and the velocity were both positive when t was equal to 4. All right, I think this is enough to get us started. Again, you're going to have to find the velocity and the acceleration at the moment in time that they're talking about, and then you'll know if the particle's speeding up or slowing down. Remember, it doesn't matter if they're positive or negative. As long as they're both the same sign, then your particle will be speeding up. And again, it doesn't matter which one is positive and which one is negative, but if they have different signs, like one is positive and the other one's negative, then that means your particle is slowing down. And it's really that simple.